Chapter 9, Lesson 2 on Prime Factorization. All right, so first thing we're going to look at is a prime and composite number. A prime number is a whole number with exactly two unique factors, so two different factors, one and itself. So for example, the number 11 is prime because the only two numbers, the whole numbers, that can multiply to get 11 would be 1 times 11. So it has two unique factors. A composite number is then a whole number with more than two factors. So 20, for example, because it has factors of 1, 2, 4, 5, 10, and 20. All right? The number 1 we often confuse. A lot of times we think it's prime. The number 1 is neither prime nor composite because 1 only has one factor. 1 is 1 times 1, so it does not have two unique factors. So the number 1 is neither prime nor composite. All right, when we talk about the prime factorization of a number, we are talking about when we express a composite number as the product of its prime factors. All right, we have two methods we're going to look at to find the prime factorization. The first is a factor tree. You might have seen this before, and you can use any factor that you want. So we're going to look at the number 120, and we're going to just, off the top of our head, think of two numbers that multiply to give us 120. So for me, the first thing that comes to mind is 10 times 12. And then I'm going to say, okay, the number 10, is it prime? No. 10 is 2 times 5. And then I'm going to say, is the number 2 prime? It is, so I'm going to circle it. Is the number 5 prime? It is, so I'm going to circle it. 6 comes from 4 times 3. You could have done 6 times 2. Okay, the only factor we don't want to use is 1 because it doesn't help us. I say, is the number 4 prime? No. So I'm going to branch it off. Is the number 3 prime? Yes. The number 4 comes from 2 times 2. 2 is prime. 2 is prime. The prime factorization of 120, we always write it in numerical order. So we say it's 2 times 2 times 2 times 3 times 5. Okay? I can also write that with exponents and say 2 to the third times 3 times 5. All right, the second method is called the cake method, and we're going to do 120 again to make sure we get the same thing. The cake method means you must use prime factors only. So what you do in the cake method is you start with 120, and basically we're kind of doing division problems, and we say, all right, 120, well, I have to think of a prime factor only that goes into 120. 2 is a good one to start with. So 2 goes into 120 60 times. 2 can go into 60 again 30 times. 2 can go into 30 15 times. 5 is prime. It goes in 3 times, and now I'm at a prime number. This right here, these numbers that I divided by, are my prime factorization. 2 times 2 times 2 times 3 times 5. Or 2 to the third power times 3 times 5. All right, the next thing we're going to look at is a monomial and how to factor a monomial. So a monomial is just any number, that's called a monomial, or it can be a variable, or it can be a product of numbers and variables. So it might be like 4a, or it might be 2ab squared, all right, because b squared is just b times b. It might just be m, or it might just be 10. Those are all monomials. But if you add or subtract something, or if you're dividing, it's not a monomial anymore. All right, if we want to factor a monomial, most monomials that we're going to look at are going to have a number and a letter. We call that number the coefficient. So when we factor it, we're going to write the monomial as the prime factorization of the number and a product of the variables. Sometimes our monomials have a negative coefficient. That means that the number at the beginning is negative. And if we do that, we're going to first factor out a negative one, and then we're going to continue factoring the monomial. And we'll look at an example. All right, so if I'm going to do the prime factorization, I'm going to factor 11qr to the fourth. This is just called factoring. It's not going to say find the prime factorization of this monomial because I don't know the prime factorization of a variable. So I'm going to start with this, and I'm going to say, well, 11, oh, that's just 1 times 11, right? So it's already prime. I don't even need to write the 1. So I'm going to write, when I factor it, 11 times, and then I'm going to write each of these variables as a product. So I only have one q times r times r times r times r. I'm not going to write my variables with an exponent. All right, if I'm asked to factor this, remember the first thing we're going to factor out is a -1. So then I'm going to do the prime factorization of 28. So 4 times 7, 7 is prime, 4 is 2 times 2. Okay, so my factorization of -28 is -1 times 2 times 2 times 7 times, and then I have a squared, so a times a, and then I have b cubed, so times b times b times b.